Hallo graad 11, die laaste stukkie van elektrostatika wat ons moet doen gaan oor die oordrag van elektrone. So ek is in julle boeke op bladsy 129 and they say how many electrons has been transferred if an object has a charge of 7,5 times 10 to the power of negative 9 coulomb. Okay, en net bo dit sal julle sien is daar so 'n formule wat sê Q is gelyk aan N key here. So let's quickly talk about this. The Q is for charge. The N is the amount of electrons. And this lowercase q with the E is the charge of one electron, which will always be equal to negative 1,6 times 10 to the power of negative 19 coulomb. Hierdie ene gaan vir julle gegee word op die formuleblad. That is a constant, so that will be given to you. Okay, nou wanneer ons besig is met hierdie, gaan jy nie die minus instel nie. So we are not going to substitute the minus. So if I ask you how many electrons were transferred if this charge was created, then you say, okay, charge is equal to amount of electrons times the special charge of an electron. En ons soek die aantal elektrone. So as ons hom gaan sit as die onderwerp, kry ons dit. And now guys, it is as simple as substituting the charge, want hulle gee vir jou die lading, en om hierdie ene in te stel, let wel, ek doen dit sonder die minus, and you get to an answer of 4,7 times 10 to the power of 10 electrons. Okay, they can go further and ask, we have two different spheres. It's the next example still on page 129. Example 2, they say, we have two different spheres. One has a charge of negative 5,8 microcoulomb, and the other one has a charge of positive 3,6 microcoulomb. I'll write down a table for you guys now with the different charges. I don't think there's one in your book, but I'll write you down one now. Okay, goed. En dan die eerste ding wat hulle vir jou vra is, hierdie twee kom nou in aanraking met mekaar, en dan vra hulle vir jou wat is die nuwe lading. So for that, we have our formula. QF is equal to QA plus QB divided by 2. So daarvoor gaan ons net sê, is minus 5,8 plus 3,6 op 2. Let wel, ek worry nie nou oor die microcoulomb nie. Ek gaan net seker maak by my antwoord, hierdie minus 1,1 gaan nog steeds microcoulomb wees. Okay, so that could have been coulomb or microcoulomb. Let me quickly just write it down for you guys. Milli, you guys know, is 10 to the power of negative 3. Micro, it's that weird thingy, is times 10 to the power of negative 6. Then we have pico, which is times 10 to the power of negative 9. No, nano is 9. Nano and pico is times 10 to the power of negative 12. So in other words, if I tell you that something has a 2 nanocoulomb charge, it means that it has 2 times 10 to the power of negative 9 coulomb. Okay, and that's going to be important for the rest of this calculation, because now they ask us how many electrons were transferred during this interaction. So remember, we had our one sphere and we had our other sphere. Both of them are microcoulomb, eh? Then they got in touch with one another and we ended up with negative 1,1 on both. Okay, so I hope you guys see that the electrons were transferred from this first sphere to the second one. Hoe weet ek dit? Want hy het van 'n meer negatiewe lading na 'n minder negatiewe lading gegaan. The electrons decreased in this first set and they increased here. Want hierdie het gaan van 'n positiewe lading na 'n negatiewe lading toe. Okay, now we need to calculate how many electrons did we transfer. And to do that, you say the change in charge. So it's the final minus the initial charge. Nou kan jy besluit, kyk ons nou na sfeer A of na sfeer B. Dit maak nie saakie. Al twee van hulle gaan vir jou dieselfde antwoord gee, die teken gaan net verskil. So I'm somewhere gonna work with, let's do sphere B. It ended up with a charge of 1,1, negative 1,1. It started with a charge of positive 3,6. So as ek hom gaan uitwerk, dan kry ek minus 4,7 nanocoulomb. Okay, in other words, the amount that the charge changed will be 4,7 microcoulomb. So as ons gaan kyk na sfeer B, onthou hy het elektrone bygekry. Hoeveel elektrone het hy bygekry? 4,7 nanocoulomb se elektrone. As ons hierdie selfde ding nou gaan doen het vir A, let me do it just so that you guys can see. It's still the final minus the initial. So remember, the final charge remains negative 1,1 microcoulomb. The initial charge of A was negative 5,8 microcoulomb. En as jy hom gaan doen, gaan jy sien jy kom by dieselfde getal uit, die teken verskil net. So remember, A lost electrons. How many electrons did it lose? 4,7 microcoulombs worth of electrons, while B gained electrons. How many electrons? 4,7 microcoulombs worth of electrons. Nou ons het nog nie gesê hoeveel elektrone dit is nie, maar ons gaan nou gaan en sê, ons wil uitwerk hoeveel elektrone het in die transfer geskuif. So how much of the charge moved? 4,7 times 10 to the power of negative 6. I got that from there. Micro is maal 10 tot die mag min 6. En ons het hier so 'n micro. So ek kan hom skryf as 4,7 maal met 10 tot die mag min 6 coulomb. So that's the amount of charge that was transferred, and I divide that by 1,6 times 10 to the power of negative 19. Note, no signs in this. Hierso is tekens belangrik, né? Maar hierso sit ons niks tekens in nie. En dan as jy dit in jou sakrekenaar gaan intik, gaan jy kry dis 3,75 maal met 10 tot die mag 19 elektrone wat gedurende toe hulle twee aan mekaar geraak het daar 3,75 maal 10 tot die mag 19 elektrone geskuif van A na B toe.